Hello and welcome to this video. We're going to talk about U-substitution and some of the fundamental things that we should know if we're going to do a U-sub problem. First, we're given an integral, the square root of 2x plus 1. It's a bit more complicated than the quadratic equation that we would have to integrate, so you have to go about it a little bit differently. The first step to U-sub is to create an integral that is much simpler than the one that we already have to work with. 2x plus 1 isn't quite integrable yet. I like that word, integrable. It makes me sound smart every time I say it. So, let's try to get something more integrable. First, I notice that I have a nested function here. I'll show you in red. This nested function is 2x plus 1, and it's inside of a radical. That's kind of like having a function in a function. And that is one tip that U-sub is probably a good choice for that integral. So what I'm going to do is, to simplify this integral, I'm going to say that u, some variable, is equal to 2x plus 1. If that's equal to 2x plus 1, then wherever I see a 2x plus 1, I can just say u. So I would have the integral of radical u. And that is much more integrable than this. However, I have a function of u with respect to x, and that is not integrable. So we would have to find a much easier, or not much easier, but we'd have to find a way to make that dx into a du. So here's what I would like to do. I'm going to take the derivative of this u to get du equals 2x plus, I'm sorry, I got to take the derivative of this side, that's going to be 2 dx. If I solve for dx, then I'll have 1/2 du equals dx. That means if I write dx, that takes the place of 1/2 du. And if I write 1/2 du, I can write that in place of dx. So let's see, I've got a u, which covers 2x plus 1. And I know that dx is equal to 1/2 du, so perhaps I can make an integral and write 1/2 du, and then I can say radical u, and I've covered all the parts that I need to cover to make an integral with respect to u. Now I can pull this 1/2 out of the integral because it's a constant. So I'll say 1/2 times 1/2 times the integral of u to the 1/2 power du. And that means I am ready to integrate. I'll move up here and I'll say 1/2 times u to the 3/2 divided by 3/2 plus c. And this is multiplied. Now, to divide by a fraction is to multiply by its reciprocal. So I can simplify this by saying 2/3 u to the 3/2 plus c. Excellent. Now I can distribute in this 1/2, and I can note that these 2's will cancel out. So I'll have 1/3 u to the 3/2 plus 1/2 c. And then we can acknowledge that c is an arbitrary number, so it doesn't matter that we're multiplying 1/2 times it, because it could be anything. And so whether it's multiplied by 1/2 or by itself, it still has an infinite amount of possibilities. So we can simplify that to 1/3 u to the 3/2 plus c. And then it's important to remember to substitute in our original u value back to x. So, going again, I have 1/3 times 2x plus 1 to the 3/2 power plus c. And if you're in a really good mood and you'd like to, we can even, well, we can't distribute that 1/3 because of that silly power right there. So I'll call that as simple as we can make it right now. This is the antiderivative of the the radical 2x plus 1 that we started with. If you have any questions about this, you can email me at jokoengineeringhelp@gmail.com or post to the Facebook page, facebook.com/jokoengineering. It's been good to have you with us, and if you have been helped by this video, please subscribe. That's the best way to help me back. Otherwise, thanks for watching, and catch you next time.